Hey everyone, I'm Basanta from Smart Tech Guide. In this video, I'm going to talk about 5G, why it's important, and why there are so many resistant and politics involved in the development of 5G. Um, this picture on the front shows um, couple of different component of 5G. 5G includes sub-6 band as well as the millimeter wave band. So it has different bands: lower, medium and higher band. The higher band is millimeter wave and the lower one is sub-6. It's also 600 gigahertz band. So let's dive in. First of all, what is 5G? 5G is fifth generation wireless technology designed for digital cellular communication, and it aggregates the sub-6 and all the way up to the higher millimeter band, wave band. So to get the blazing fast speed, higher speed. It has very wide dynamic spectrum, and it has very good dynamic spectrum sharing. The lower band 600 megahertz is shared between the upper LTE band, and it can co-work with upper LTE band along with the 5G, because it's not fully using the 600, but it uses 600 along with the higher bands to get the better speed. And it has a broad coverage, like I mentioned before, because of higher spectrum, wider spectrum. It has broad coverage and high speed. It can be used in various of devices, such as Internet of Things, IoT and all those things, and it can be used to control devices, self-driven cars, autonomous device, and connected roads. All those things it can be used. It delivers very high speeds. The theoretical speed limit reaches all the way up to 10 to 20 gigabits per second. But the real life, it may be little less, but 10 Gbps is not a small thing. It has very low latency and massive capacity, like I mentioned before, because of the broad coverage and broad spectrum. It has a high capacity, and it is capable of uniform user experience. This picture I showed you before on my previous video about the Qualcomm Snapdragon X60. That's a 5G modem that Qualcomm developed recently. If you haven't watched that video, feel free to go and watch. I'll add the link on the description section, and on the suggestion up on the top right corner. Here it shows three different bands. The sub-6 is also called lower band, and another sub-6 is divided into two bands, basically mid band and low band, and the millimeter wave is kind of high frequency. It's upper band. The upper band frequency goes all the way from 1 gigahertz all the way up to 72 gigahertz, and it depends on which country and which region you are in, so and which network you use. So not all the network use same frequency. It's divided between different networks, and different frequency may be there for different networks. So but the upper band goes from 1 gigahertz all the way up to 72, but most used frequencies are 1 gigahertz, 2.33 and 6 and 24, 25, 26, 27, 28, 29 gigahertz, kind of that, but it can go all the way up to 72. By combining all these three different bands, the uh, throughput is very high. That means the data rate can reach very high. The lower band has very low data rate, like maximum of 100 mbps, while the higher band has as much as 20 gigabits per second. So when combining all together, it reach a higher throughput along with the consistency and uniform user experience. How does it work? Like I described a little bit in the earlier slide, uh, it has three different components: lower, medium, and upper band. Higher band, the lower band somewhat collide with fuzzy LTE, so it has to work with dynamic spectrum sharing along with the fuzzy LTE. And the upper band, it's totally new radio. NR is called new radio. It's the frequency from 1 gigahertz to 72 gigahertz that I mentioned earlier. This picture I grabbed from the GSMA ITU. ITU is International Telecommunication Union, and it's about the 5G. This picture was about the 5G. There is one PDF about the development of 5G, and I grabbed one of the picture from there. LTE is not suited for millimeter wave deployment because of loss and all those things, but with 3.5 gigahertz, the loss can be compensated by using MIMO, that's a multiple antenna system within single device. So the loss can be compensated, and another way it can be compensated is beamforming. What does that means is the antennas are focused on particular direction, so it forms the directional beam, so that communication has direct line of sight kind of thing, so less propagation loss. And below 1 gigahertz there is very limited spectrum available, so the higher data rates cannot be achieved. But if we go up above 1 gigahertz, the spectrum is very wider, all the way up to 72 gigahertz, and in the gigahertz range the spectrum it can take as much as need. So that means it can achieve very high data rates. That's also over here I mentioned 100 mbps for less than for the LTE band, or the lower some 100 megahertz frequencies. In the mid band it can reach up to 1 gbps, but if you go to higher band it can reach up to 10 to 20 gbps depending on which frequency we are using again, because of it reaches from 1 gigahertz to all the way to 72 gigahertz. If you are using 72, then it may reach up to 20. If you are using 30 or 32 gigahertz, then it may be 8, 9 or 10 gbps. Next, what are the pros and cons of 5G? Right in the right side, I grabbed two screenshot, one of my phone and another from my friend. It shows the LTE data rates, the exact data rates that we use every day on LTE network. The lower one is T-Mobile LTE, and that's a little bit slow in this area, but it can reach up to 10, 12 mbps. And the upper one is Sprint LTE, and it has already kind of typical range. Over here internet speed is typical, here internet speed is slow. This is my T-Mobile, and it is a little bit slow in this area, but the typical range of the download and uploads are kind of 10 megabits per second and 1 megabits per second on average for LTE. That's real usable data rates. But if we think of 5G, it can go all the way up to at least 100 Mbps from the user perspective. In earlier slide I said it can reach up to 1 Gbps or 10 Gbps depending on the frequency. That is shared spectrum, so user won't be able to view that data rate, but as the data rate shared data rate goes up, user can get the higher bandwidth and higher data rate. So that's the theory. So if you are using 5G, you may be able to get at least 100 Gbps, 100 Mbps of data download speeds, and maybe 10% of that as an upload speed. Pros and cons: it has peak data rate, achieving real world speeds. Theoretically, it can achieve very high speed. That's why I'm saying here real world speeds. You won't be able to get exact 10 Gbps or so, but you may be able to get 100 or 200 Mbps. That's absolutely perfect, and you can download a whole movie within couple of seconds with that speed. Low latency, it won't have any delay and any latency in the communication, so that's a good thing. For the efficiency, it may have some side effect, like energy wise it may have some extra power consumption, but that can be manipulated with the idle state management. If the device can go into idle state when it's not communicated, then that can be improved. So though it's a negative side, but it can be improved with the little bit tweak on the idle state management. And spectral efficiency is very high because it has wider spectrum. Again, it can utilize the wide spectrum, and it can achieve the better efficiency. Mobility, not really, because it has to use the lower frequency to achieve the mobility. For 4G LTE, mobility is very nice. It can reach very far. The signal can reach very far, and very far in the sense hundreds of miles from a single towers. But if you go up to millimeter wave, 1 mile, 1 square mile is the much it can reach, because millimeter wave cannot penetrate through the walls. That's negative side of the 5G, higher spectrum 5G. So carriers has to build so many towers on every miles or so. That's another thing carrier have to do. But from user perspective, the mobility is not that well on the millimeter wave side, but it can be achieved with the lower band, the soft 6 band. That's why 5G has to utilize both lower, mid, and higher band to get the better speed as well as mobility altogether. To give user a uniform experience, it has to utilize all three different spectrum altogether. It cannot use only one and get the higher speed along with the mobility and everything. and mobility has to be there. For example, if you are traveling in train or car, then you have to get the signal, right? So you'll be traveling in 30, 40, 50 or 100 mile per hour. In that case, if the towers are located every mile, it has to switch within a second. So that should be handled. For that, the lower band comes into picture. uh, Connection density, because of higher spectrum wider spectrum, it has very high connection density, and many people can use it, and higher the download and upload speeds. Usage, a couple of things I mentioned earlier. It can be utilized in various things, including IoT, Internet of Things, remote controlling the devices, autonomous vehicles like and connected roads, connected cars, so many things. And connected infrastructure. Think of like a traffic light sense the person coming nearby, and place the red light for the coming car, and car stopped, the autonomous car stopped because it senses that red light from the road. So it can intercommunicate between all together, so that's connected things, and it can be achieved with 5G. 5G will have improved broadband because of high speed and all those things, as I mentioned earlier. It can be utilized in military, it can be utilized in healthcare, public safety and infrastructure, and many more. On top of that, regular voice, text and data. That's the main thing, regular voice, text and data usage. And again, voice is over NR, and it won't require the regular cell phone tower, but it can utilize the data itself to carry the voice and text. It's also called voice over NR. Next, this is one. Are there any resistance or any politics involved? Of course, there are some resistance. There were some resistance and some kind of politics, and still going on, kind of. The first one is kind of health side. There are some people, including some professor from the renowned university, were lobbying for the kind of antitrust thing for 5G development, because of its it collides with microwave band. Electromagnetic radiation affecting people and the planet, kind of, that was the antitrust movement. Microwave frequency is 300 megahertz to 1 gigahertz, or little above 1 gigahertz, 2 to 3 gigahertz, and it's basically 1 meter to 1 millimeter in the wavelength perspective. Couple of range of 5G collide on that range, as I showed you before. 600 megahertz, those kind of thing fall in that category, but it's nowhere near to the power level of for the ionization of biocells. So it cannot hurt because of it's very low power compared to our regular micro oven, oven in our home, so it does not hurt biocells. But that was kind of antitrust movement filed by a couple of professor and even political leaders, and that was kind of resistant for some time. Right now this is is kind of settled down, but still there are a couple of groups that is still focus on this kind of thing. And if you see this picture, it shows like extreme low frequency radio frequency, that is what we are using for mobile communication, and microwave frequency, the couple of the lower band of the 5G falls inside that microwave band, and it goes all the way up a little more further. If we go above a couple of gigahertz, and then it comes to the visible light spectrum from the sun, and then it goes to ultraviolet and X-ray, and then gamma rays. The ionizing level start from X-ray, after X-ray, kind of mid ultraviolet place. So anything below that point, it's not harmful for the biocell. Anything below the ionizing level, it's not harmful for the biocells. This picture I grabbed from Wikipedia, and this is similar picture, but it shows a couple of different use cases. That's why I wanted to share here. And this is electromagnetic spectrum. It shows the wavelength and the frequency, and it also shows the non-ionizing and ionizing frequency levels, and it shows what are the things that generates a different frequency. Earth and subway, very low frequency. AC power 50 hertz, that's very low again. CRT monitors, couple of thousand, and AM FM, couple of thousands to megahertz, kilohertz to megahertz, and TV even further, some gigahertz. Cell phone again in the same range, radio frequency, and it goes beyond microwave, and then this 5G band, and then further the sunlight spectrum, and then further the X-ray and gamma rays, and that where the ionizing starts right after the mid of ultraviolet range. The main harmful frequencies are X-ray, gamma ray, and the radioactive rays. So 5G is not harmful for biocells. Further, there's also a kind of claim of spying on the other nation's citizens. For example, China is developing 5G, and United States or some other country claim that China is trying to spy on other countries' citizen, or vice versa. That kind of battle is there from one country to another. That's a kind of politics, I think. Even they are not, even if they are not doing any spy on the citizen, that's a politics to the things where who goes first. So that's where it comes the point of financial benefit. If someone goes first, and then they can carry the whim, then in that case the financial benefit go to that country. So for example, if China is able to lead on the 5G, then most of the financial benefit comes to China. Or if United States or some other country can lead on the 5G, then they will get the financial benefit on that. So that kind of thing is driving the spy claim. It may be real, it may not be real. One other thing is space race. Elon Musk SpaceX project, also called Starlink, has received federal approval to launch 12,000 satellites. That's huge number. 12,000 lower Earth orbit and medium Earth orbit satellites. With that, they will be able to launch satellite and spread the 5G from the satellite itself, because as I mentioned earlier, 5G has upper band that cannot penetrate the walls, and it cannot reach far away if it's blocked by some wall or mountain. So if it can be done through satellite, it will be a direct line of sight, so that's better thing. That's the project Starlink is about. If they are able to get 12,000 satellites on the sky, they can dominate the 5G market. And some other companies like OneWeb, Boeing, Amazon are also getting a couple of thousand satellites. So with that, the winner here is Starlink from Elon Musk SpaceX project. If they launch all those satellites, they will dominate the 5G market. This is one different aspect of the resistance, who wins first and who gets many satellites, or who gets the lead on the 5G market, that kind of things. That's all. Thank you for watching. Thank you for watching my video. Please subscribe and share my channel and videos, like my Facebook page, and don't forget to click on the bell icon next to subscribe button to get notified of my future videos. If you haven't watched my previous videos, go ahead and watch. Feel free to comment if you like to know something or have feedback for me. Until next video, have a good time. Bye bye.